So for today's lesson, we are going to be covering casting and random variables. So let me share my screen with you so you can see the notes for tonight. But before I start, can you guys write in the side what you have already covered this week in your classes? Or if you know what you're going to be covering next week, that would be great. And in the meantime, while you guys are sharing what you just finished matrices, I will begin sharing my screen. Okay, cool. So we're going to go ahead and begin with casting random variables. So we have different ways to cast in Java. So we have to either implicitly or explicitly cast our numbers. So for example, can anyone tell me what we get for the first one? Do you think you'll get the answer 1/3 in the form 1/3? Do you think you'll get 0.33333? Do you think you'll get 0? Maybe you'll get 1. If you guys want to just type your responses, that would be great. And yeah, so for this first one, neither the 1 nor the 3 are casted to doubles. So you guys got it exactly right. We're going to get 0 here because the compiler is seeing these as 2 integers. And so when you divide into 1 by 3, you're going to get 0. So the next 3 bullets are when we get into kind of implicitly casting into decimals. So for this multiplication, or in this case, for this division to work, what we have to do is either with the first number, the second number, or both numbers need to be cast into doubles to get the right answer, the 0.33333 that we're looking for. So in this case, we cast the first number, it's 1.0, to a double, and that's why we would get the right result, which I'll show you in a second. And the second or the third example here, we casted the second number to a decimal or a double. So then we would also see the 0.333. Or you can do what we did here in this last bullet by casting them both from integers to doubles just by adding that 0.0 at the end. And that's just a nice trick so you don't actually change the value of the variable you're dealing with, but rather you're still allowing to do the division and get a decimal answer. The other way to go about casting is to do the division itself, but then you can add these bracket or these parentheses with the type of variable you want to cast to before it and still get the answer you would like. So for example, you can do parentheses double 1 divided by 3. But one important thing to note here is when you add a cast, for example, here we added double, casting what comes immediately after that. So for example, right now, the 1 would be the only variable here besides the product, the product that would be a double. The 3 here is still seen as an integer. One way to change that, though, if you wanted both the 1 and the 3 to be seen as doubles, is you would have to put parentheses on both sides of this. So then the double would then evaluate and be applied to what's inside the parentheses. In our case, it would be 1 divided by 3. Another important thing to note here is that casting for like integers, doubles, only works of things of the same type. So like primitives can only be cast with primitives, and objects can only be casted with objects. For example, because a string is not a primitive, but rather an object, int a equals int quotations 8 quotations would not work. And this is because even though 8 is a valid integer, there really could be anything inside those quotation marks, and the compiler doesn't necessarily know that. So that direct casting method right here would not work. The other example would be doing the same thing but backwards. String b equals 8 would not work because the compiler doesn't understand why you're passing in an integer instead of a string, because it really expects to see those brackets there for initializing it. So now we can go over to an example of this. So kind of what we did before. Give it a second, it's being very slow today. Oh, Java stopped responding. This is great. Okay, I guess you'll just have to take my word for it that the first one results in 0, and then the rest of them, these three, result in 0.33. And then that for this one, only one is being casted into a double, not 3, unless you add those additional parentheses, and that these two results in compiler errors. To see this yourself, I highly encourage you try it out in Java, whether it be on your own or right after the webinar. And yeah, does anyone have any questions on casting before we move on to random variables? Any questions? Okay, so if there's no questions, we're going to go ahead and move forward with our random variables. So for random variables, the way the AP exam likes you to do it is by using math.random. The other way to do it would be creating a random object, but because we haven't gotten into objects, we're just going to stick with the math.random. Have you guys covered random variables yet in class? And if so, did you use math.random or did you use the random object? Okay, you guys have been using the random object? Okay, so we can go over that as well. So the one thing that's good about math.random as opposed to the random object is with the random object, you have to create a separate object itself before you can start using it. But the random object does provide some additional benefits as opposed to math.random, because the random object allows you to specify whether you want next int, next double, next char, next boolean, for example, while math.random only returns a result that's a number between 0 and 1. But it doesn't actually include 1, it just is a double from 0 to 0.99999, kind of going on forever. But with a little bit of math, we can get this to another form. For example, what we would have to do is we would take our result from math.random and multiply it by our range. So if you take the maximum number of your range and you subtract the minimum number, then you can multiply that by your math.random result and add the minimum value to get the number you need. But one important thing to note is the difference between max minus min and max minus min plus 1. So if you want your range to be inclusive, that is including the min and including the max, you'll have to add the plus 1 to your range. However, if you want your range to include the min but go opposite but not include the max, you'll do max minus min. Because the result will never equal 1, this, like we saw before, Java is always going to round down and just chop off the decimal. So that's why we add this plus 1 in here to make sure that that max value can be reached in its entirety. So then we're going to add the min value after we have multiplied by our range, and then we're going to cast it, if necessary, to whatever form we're looking for. So let's go. Hopefully Java's working this time. Okay, perfect. We'll go run through an example here. So I guess we can start off with our casting example. So if we have int a equals 8, add a semicolon there, we'll see that Java doesn't like this, and that's because it's getting a string instead of an int. Even if we put a cast here, it's still not going to like that because you're trying to cast an object into a primitive, and that just doesn't work. Another thing, so if we try it now, change this to string a equals string 8. Again, we see Java doesn't really like this. Even when we cast into string, even if we remove this string here, Java just does not like the cast from primitives to objects, and that's why we constantly see these errors. So with all that aside, we can then go on to our randoms. So here, if we have a random object, so both of you, I'm guessing, are familiar with this format though, random gen equals new random, and then like we can print out gen.next. Please respond. Or gen dot, that should be followed with next int. So does that, gen dot next, there we go. Let's see what it's telling me. Okay, so random, oh, because with randoms, another important thing to note is whenever you use them, one of the reasons why they're more complicated is because you have to have your import statement. Does this sound familiar to you guys? About having to import java.util, and then you can do either .random or you can just do .star as a good way to just import everything all at once. So now it should recognize it. Okay, I don't know why this is not working and recognizing it. But anyone seeing my error, I know you guys are more familiar with the random generator than I am. But because the random class has requires the import and requires an additional object, it tends to be a lot more complicated to use than just what the AP usually expects of the math.random. They will take both as acceptable answers, but you should be familiar, especially with the math.random form, since that's what they'll use in the multiple choice question. So, okay, so I'm gonna then show you how to do this with the math.random because Java does not like me right now, but it's okay. It's a love-hate relationship sometimes. Everyone will encounter hard times when they are coding, and sometimes you'll just learn how to get around them. So if we have now a random number, here in this case we'll have a double, and then we're just going to run this a few times just to show you that it is in fact a random number between 0 and up to, but not including 1. Okay. Oh, yay. So yes, that works. If you can see, the result will be randomly propagating. Okay. And we just get a few examples of that. So we can combine math.random in our statements and try casting it. Let's say we want an integer out of this. If we don't multiply it by anything, what do you guys expect the result to be here? Any guesses as to what will be printed? No, a random integer is actually not the correct answer. Remember, math.random gives you a random double between the numbers 0 and 0.999999. So if we're casting this to an integer, 0 should be printed the whole every time, because what's going to happen is the numbers and the decimal is going to be truncated. So yeah, no matter how many times we run this, we will always see 0. Okay, so but we can change that so we get something else besides 0 by multiplying this by a range. So let's say we want a number between 90 and 100, because we always get A's on our exams, and that's going to be representative of our score, for example. So first we're going to multiply by a range. So our range is going to be 100 minus 90. And so we want this to be inclusive of 100 because we like to think perfection is possible. And then here we have to add our minimum score. So in this case, it would be 90. So if we go ahead and we run this, so 90, for example, so that shows right away that the minimum bound can be reached. And there is a random number in here. Oh, so can anyone tell me why 90 is constantly being printed? And we're not seeing random values. Any guesses as to why it was always 90? It's not a coincidence. Yes, that's like, you guys seem to really get the idea. It's because the math.random is being cast into an integer, and we don't have parentheses over the whole thing. So adding these parentheses allows the integer cast to be applied to the result of this whole thing. So here we would still have a double multiplying by the integer. So double multiplying by integers is still double. And then after that, it would finally be cast in it. So yeah, you guys seem to really understand the idea of casting, in that these parentheses are important to making sure we get the right result. So if we run this program now, we start to see we can get 95, 98, 100, 99, and just a bunch of values. So if you could see earlier, we got both 99 and 100, and that's because this +1 allows that to happen. If we took out the +1, no matter how many times we ran this, we would never see the result 100, because again, the greatest value math.random can return is 0.9999, which will always get truncated when multiplied by this to like 99.99999, which would turn into 99. So no matter how many times we run this, I'm not going to run it forever since we have other problems to do, but you would always get up to, but not greater than 99. Okay, so let's try another example. Can you guys tell me a range between 100 and 99? Add the +1 back in, so 100 is now a valid answer. And let's do, actually, I'm going to change it up to a double for this problem. So let's say we have a double that equals math.random. So just a random integer. And then we print out it out twice. What do you think will be printed here? Do you think the same number will be printed twice or two different random numbers? Yeah, nice job. So yeah, the same number will be printed twice here. We can see that by running the program. We'll have the same number once and again below it, and that number again will be between 0 and 0.99999. What if we did this? Now, what do you guys think will happen? Do you think that the same random number would be printed, or a different random number would be printed each time? Yeah, nice job. It would be a different number. Although one could argue that math.random up here is the same expression, every time math.random is called, it will generate a new random number. There is the 1 out of a million or so chance that they are the same number because math.random generates the same number twice, but that is highly, highly unlikely. So as we run this program, we'll see that it's two different numbers that we're going to be generating each time. So does anyone have any questions in regards to random variables or casting? Any questions? No? Okay, so if you guys don't have any questions, I'm going to turn it over to Seven, who's going to walk through a set of practice problems for tonight for you guys to do on your own, and then we'll go over those answers to make sure you guys get a real good grasp on the material. And it's in that time, if you guys think of any questions, we can answer them then.
All right. Hello. Oh, so dark. I'll send the link to the question problems in the chat. So if you guys can fill that out, and I can go over it when you guys are done. All right, since both of you guys submitted your responses, I'll go over them with you guys. And okay, I think you guys did pretty well in general, but let me just go through each question. Okay, so number 1, what does that equal? I'll just quickly go over the question with you guys. My notebook. Okay, so if you look at this one, we're doing order of operation. So as we have talked about this last week, we said that this division sign and mod sign have the same hierarchy, so we just read from left to right. So we do 6 divided by 5 first, which is just an integer division, so that becomes 1. And then in this equation, we do 9 mod 10, and we know that that one returns a 9 because 9 divided by 10 gives a remainder of 9. So then it just becomes 2 minus 1 plus 9, which becomes just 10. That's just a simple math equation. And number 2, which of the following returns 9.8? Select all that apply. So basically, the first one is correct because you have 6.0 divided by 5. So that returns a double. And then when you do 2 minus that number plus 9, you get 9.8. Choice B actually gives an error because when you do 6.0 divided by 5, that returns a double, but you're trying to store that double into an integer. So Java won't allow you to do that, so it'll return an error. And choice C is also correct because you are casting 5 into a double. So when you do 6 divided by 5, that's not an integer division. So that just returns a double. And same thing as D. You're just casting 6 into a double. So that's just like the same thing as 6.0. So that also returns a double. Now, choice E is incorrect because instead of casting 6 or 5, which should return a double, you're just casting integer 2 because, or so when you do 6 divided by 5, it just returns an integer division, so that doesn't give you any decimal points. And then choice F is also true because you're casting 5 into a double. So when you do 6 divided by a double 5, you get a double answer. Now, next question is true or false. Java rounds up automatically when you do integer division. So that one is actually false because Java doesn't round up, but when you do integer division, it actually rounds down by just cutting off the decimals or just like truncating them. The next question, which of the following returns the correct average when 3 values had been added to an integer total? So when you look at this one, the first one is true. I mean, first one is false because when you do total divided by 3, that actually is an integer division. So that'll just give you an integer for by truncating them. So when you actually double cast that integer to a double, that doesn't really return, it doesn't give you anything. It just means like, just means nothing because you're just doing integer divided by integer. So you lose information. And same thing as the second option, when you do total divided by 3, that's still an integer divided by integer. So that'll just truncate your decimal points. So the last option is correct because when you do total and you cast that to a double and divide it by 3, that is not an integer division. So you get a correct average value returned. The next question. Write one line of code using math.random to generate a random integer numbers between 5 and 10. So the formula that we gave you guys, or a simple formula that you guys can use for this equation is, let me just show you one more time. I know Jack went over it. but it's just when you call math.random, you have it multiplied by the maximum minus minimum plus 1 if you want to include with the inclusive plus the minimum. So when you do max minus min, the computer knows that which range they want to generate the random values in, and then when you do plus min, it knows like from where to start, from which number to start. So the answer to that will be just 10 minus 5, and then parentheses you want to do plus 1 because you want the numbers to be 5 to 10 inclusive. And then outside of the whole parentheses, you want to have plus 5 to let the computer know that you are starting your random integer from 5 and you want your range to be 5. So 10 minus 5. And then last question, you guys all got it correct. Given the following code segment, what is the value of num when it finishes executing? The answer is D, because the range from -5 to 5 is 10, but because you want 5 to be inclusive, you do plus 1. So you get value times 11, and then because you want to start from -5, you do plus -5 at the end of the parentheses. So that is it for the questions for this week. Do you guys have any questions? Okay, sounds good. So that's all we have for today's webinar. And next week, we will probably start on strings. And we're covering the same material on both Wednesday and Wednesday and Sunday at 8 p.m. So you guys can choose either time to come to the webinars too. Okay, do you have anything else to say, Jack?
Thank you both for coming tonight. We really appreciate it. Hope the material makes more sense. We look forward to seeing you guys next week.
Okay. Bye.